10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Assalamualaikum and very good day to everyone. So today we're going to proceed with our first topic, which is Introduction to Engineering Materials and their effective use. What are the learning outcomes that we get at the end of this topic? So at the end of this session, students should be able to first to identify the primary engineering materials. Second, to relate the applications of the materials in practice, and to discuss the factors inclusive or criteria for material selection for civil engineering applications, and to discuss innovations, new applications and new construction materials for sustainable development. Right, we go on to introduction. What is a structure? First, we have buildings, bridges, wall and other shapes. And the structure is to resist any applied load without losing its strength and any appreciable deformation. So what are the purpose of structure? To transmit all applied loads to the ground. What are the common structural elements? We have beams, we have columns, arches, walls, trusses and foundations. So we have a few examples of engineering structures. We have first one dam, which is Hoover Dam. Hoover Dam located at Las Vegas, Nevada. And then we have offshore platform, which will be the offshore platform holding in South Elwood Field, California, CA. And then we have type of structure. We have trusses, we have beams, frame, shell, cable and arches. There are a few types of structure that are available in the whole world, worldwide. Some few are very beautiful, very quite a significant structure that can be seen in the worldwide, in the whole world. Okay. Next one, force in members of frame structure. So we have road, we have column or beam, slab. So how did the load being transferred? So how the structure reacts due to loads? These are a few questions that needs to be understood. So we have frame building. We have the vertical element, we call it columns. For the horizontal bed, the beams, and the flat surface on which you can stand is the slab. And so this building has ground floor, first floor, second floor, and terrace floor. And this building is a frame structure. You can see we have slab overhanging cantilever, we have beams, columns, and ground floor on the floor. So the load is transferred from the top until to the bottom. Alright? Slab. Okay. What are the historical development of construction and uses of construction materials? So we have the first one, early Stone Age habitats. So natural shelters such as caves, rock is for protection purposes. So in late stone floor walls at the entrances and fireplaces. And then we have river valley civilizations. The first steps in permanence. So houses were constructed using sun-dried bricks. The bricks were made from mud, straw, which were abundantly found in the river flood plains and were mixed together. And then this wet mud and straw mixture was formed in a wooden frame. And then we have construction in ancient Egypt. So the main structural materials used in ancient Egypt was stone, mainly limestone. The rough stones were used in building interior walls and foundation, which fine stones cut out with special care were used in decorating main walls or erecting colossal temples. And then we have construction in the Greek area. Use of the stone construction continued. Metal dowels and clamps were employed to fasten the stone pieces together. So we have a few historical developments during the Stone Age habitats until to the construction in the Greek area. These are the historical development of construction used in construction materials. And then we continue with this historical development of construction and uses of construction materials. So then we continue with construction in Romans time. So the Romans made great contributions to construction and developed key different construction methods. The first one is stone and masonry, and then we have second one the concrete construction, and the third one timber and metal. And then in the early industrial age from 18th to 19th century. So construction activity in the initial stage of the industrial age, that is in the later half of 18th century, can be summarized by one single term: mass production. Unforeseen innovation in technology made my new building prototype possible during this period. So the method used by this program were iron members as the structural frame and the balloon frame. And then construction in the 20th century, high-rise steel structural buildings, high-rise steel structural buildings, high-rise concrete buildings, and this type structure was usually constructed with either concrete or steel. Or two main material, concrete and steel. Either concrete we use or steel. Mainly we use concrete because steel is quite expensive to use. Alright, and then the introduction to Indian material and their effective use. We continue back with the first topic. So the basic material used in civil engineering applications or in construction projects are: the first one, wood. Then we have cement and concrete. We have bituminous and bituminous materials, then structural clay and concrete units, and then we have reinforcing and structural steel. These are sometimes called structural materials. Okay. All these materials are employed in a variety of civil engineering such as dams, as shown previously. We have bridges, we have roads, we have foundations, Luke retaining structure, waterfront construction, building and retaining walls. All these basic materials being used for all these types of civil engineering structures. Okay. So we have a few examples of civil engineering structures. The first picture we can see on the slide this is foundation. And the second one, roads. And then third one we have retaining walls. And then we have dams. Okay. And then we have liquid retaining structure. And then we have bridges. Okay, all these important parts of civil engineering structures. Foundation we use to, before we can construct any buildings, we need to lay down foundations. And then we have roads, a few roads, up and down roads, going out, going in, and then retaining wall to sustain for the earth behind the retaining wall and so on. Alright? Types of engineering materials. Okay. So basic types of engineering materials are wood, number one. Okay. Number two, cement and concrete. Third, bituminous and bituminous material. Fourth, structural clay and concrete units, and reinforcing and structural steels as shown in previous slide. Alright, this is types of engineering materials. We look to number one, timber and wood. Timber is derived from trees and can be put to use directly as pieces of lumber cut from a log or as a raw material in the manufacture of various wood products or manufactured components. And timber is a term to describe wood that has been processed for structural use. Its properties are varied between species, between trees of any one species in different parts of tree and different directions. It is light but strong and tough. So it has good thermal insulation, better fire resistant than steel, and has attractive appearance. This is basically what is timber and wood, or timber, or we call it wood in some part of the country. Some part of the country call it timber and some call it wood. Alright? This is important, a key point. Alright, then timber is widely used for example, we use it as construction projects. In construction project, we use it on the roof truss. And we use it as a formwork, as shown in the figure, right? So we have the trusses, and then we have second figure is for formwork, and third figure also formwork, and fourth figure also formwork. So the fourth formwork is for the column, third figure for the beam, and then the second figure is for footing, right? Foundation. All these formwork used to cast the concrete. The first is roof trusses, use timber or wood. Right, so next one, cement and concrete. So concrete is one of the most common construction materials in which Portland cement is the essential gradient. Sometimes admixtures are required for specific purposes. So we have aggregate, we have water, we have cement mixed together to form concrete, and then we add an admixture, right? This is a few examples of used cement and concrete. We have spray concrete. We spray concrete on the wall, on the structure, and then we pump concrete on the left figure, and then we use concreting. We use a machine to strengthen to lay down the concrete evenly, and then we have self-leveling concrete. It can level, the concrete can self-leveling by itself. It's shown on the fourth figure. So we have 1, 2, 3, 4 figures, all relates to cement and concrete. Right, so next, bitumen and bituminous material. So we have bitumen or asphalt, we call it, is the residue obtained from the distillation of crude oil. So bituminous binder, bituminous and tar are generally used in civil engineering in combination with stone or mineral aggregates. So the main area of it is road construction. This in the figure is a bitumen used for roadworks, for example. Okay. And then we have structural clay and concrete units. Best of civil materials. So we have typical structural clay, building brick, cladding brick, terracotta facing tile, we have roof tile and drainage pipe. These objects are made from commonly occurring natural materials which are mixed with water, formed to desired shape and fired in a kiln in order to give the clay mixture a permanent bond. So we will have first example clay brick figure and then clay brick paver. Alright, two types of brick, clay bricks. Alright. This is brick used for normally for walls to construct walls, right? And then for pavement we use also bricks, clay bricks, right? Alright, this is a few types of example used for clay partition wall, and then we have a clay brick wall. And then we have clay roof tile. And then we have clay drainage. Use clay product. As previously I mentioned, sorry, not a pavement, but well, not pavement, but it is used for wall. Okay. This is a few types of structural element that use clay, right? Brick clay. Next up is reinforcing and structural steel. Right? Steel is used in a variety of types and forms in every building. Typical applications of structural steel are industrial buildings, bridges, high-rise buildings, spectator stands, stadium, galvanized electricity power supply pylons, welded pipelines, and others. Perhaps the greatest disadvantage of it is the need to protect them from corrosion. This is an example of steel used for slab casting. You pour concrete inside the formwork, mixed together with the reinforcement steel. So the weakest point is steel exposed to the environment, and then corrosion will happen. So you need to protect steel from corrosion. This is one of the few disadvantages using steel. Right. This is a few examples. Football stadium uses steel roof truss on the football stadium. We have bridges using steel to cross over the river, and then we have electricity line using steel. Okay, factors choosing construction material. So we have cost, time, availability, durability, and material properties. So the first one, cost. Cost calculation must include the initial cost of purchase and the life cycle cost of materials. Life cycle costs include maintenance, replacement, demolition, and disposal. Okay, time. Select materials and systems for ease of construction and installations. Complicated construction installation with close tolerance can result in greater wastage or even rework and more time being required. And then availability, long delivery lead in time must be allowed for as delay may cause project hold up in cost and energy losses. Durability, number 4. A highly durable material may provide the most sustainable solution if it reduces maintenance or replacement requirements, but materials should also be appropriate to the expected life of the building. The fifth point, material properties. Important in order to ensure each material chosen has fulfill the entire requirement in terms of physical, chemical, and mechanical properties. This is a few 5 key elements in choosing construction materials. And then properties of engineering materials. Materials for engineering applications are selected so as to perform satisfactorily during survey. For example, The material for highway use should be possess adequate strength, rough surface, and sufficient rigidity. As water-retaining structure would be built with a material that is impermeable, crack-free, strong, and does not react with water. And road surface needs such material that show little movement under the impact loads, water resistant, and also it is easy to repair if anything happen on the side. Okay. So we continue with property of engineering materials. And the performance requirements or property specification are not the same for all structures or structural material. So what to expect of a material used for the production of liquid retaining structure are not the same as the chosen for pavement. So to evaluate the performance characteristic of engineering materials and to assist an engineer in selection of the most appropriate and economical material for a particular application, we need to study the properties of the material itself, material of the production itself. So the common property of engineering materials are grouped under three major main headings. We have physical properties, we have the mechanical properties, and the last one is chemical properties. These are the three key major headings that we need to consider when in terms of properties of engineering materials. Alright, we continue with the common properties of engineering materials are grouped under three major headings as mentioned previously. We have physical, mechanical, and chemical properties. This is the key common properties that needs to be considered. Right? So we look at the first one, physical properties. What are the physical properties? Physical properties are those derived from the properties, matter, or attribute to the physical structure, which include density, porosity, then we have void content, moisture content, specific gravity, permeability, structure, whether it is micro or macro. And then physical properties are helpful in evaluating a material in terms of appearance, weight, permeability, and water retention of a structure. Okay, so there are a few physical properties can be derived from the property matter or the attribute of the physical structure. These things that needs to be studied further, needs to be understand further. Alright, mechanical properties, second one. Mechanical properties measure the resistance of material to apply loads or forces. Some reflect the strength of materials, whereas others measure the deformation capacity of the stiffness. And then strength is a measure of the maximum load per unit area and can be in relation to first tension, compression, shear, and then we have flexion, and then we have torsion, and then we have impact. So if you compare the physical strength of one individual with the emotional strength of another, we know that the two strengths are not the same. It's not the same, and that the comparison is inappropriate. The same reasoning can be applied when describing the strength of the material. So it is important to specify the type of strength. Right? This is all related to second property, which is mechanical properties. Okay. Alright, and then we continue further on the second properties, So example of mechanical properties. For example, we have first one, strength. It's a measure of maximum load per unit area and can be in relation to tension, compression, shear, pressure, torsion and impact. And then we have fracture. Brittle material typically fracture suddenly when the static stress reaches the strength of the material, where the strength is defined as the maximum stress the material can carry. On the other hand, a ductile material may fracture due to excessive plastic deformation. And then we have elastic. If a material exhibits true elastic behavior, it must have an instantaneous response to deformation to load, and the material must return to its original shape when the load is removed. And then we have deformation. Material deform in response to loads or forces. The amount of deformation is proportional to the property of the material and its dimensions. And then creep. Creep is generally associated with long-term deformation and can occur in metals, ionic, covalent crystal, and also amorphous materials. And then chemical properties, third properties. Okay. So chemical properties are those pertaining to the composition and potential reaction of material. So the compound of the composition, such as oxide and carbonates, describe the chemical nature of the material and the way it will behave in certain environment. For example, by reviewing the composition of principal compounds in various cements, we will be able to choose the right type of cement for a particular application. Right? So in this section, we need to use this cement. For this one, for example, we need this cement. So we can choose which cement that is suitable for any application that we use in the construction industries. For building, for example, for bridges, for example, and so on. So what are the causes of deterioration of concrete structure? So deterioration, defect, or a failure of concrete structure could occur due to many causes, such as due to physical, mechanical, chemical action. So for example, physical action, we can have an exposure to extreme temperature, fire damage, frost action, freeze-thaw action, volume changes due to temperature and humidity gradient, differences in thermal coefficient between aggregates and cement-based material. These are a few actions that can cause deterioration to concrete. Right? The first one, physical action. Right? Next is mechanical actions. The previous slide is physical action, now mechanical actions. So a few actions: abrasions, impact when handling or construction vehicle, etc. Erosion, cavitation, overloading and fatigue, cyclic loading, in terms of cyclic loading, blast, explode, right? These are a few actions that can cause deterioration to the concrete due to mechanical properties. Mechanical actions. So for chemical actions, we have sulfate attack, alkali aggregate reaction, in terms of alkali silica reaction and alkali carbonate reaction, carbonation, chloride attack, corrosion of reinforcement. And then we have acid attack on surface reaction by acid rain, aggressive chemical, industrial environment, and etc. Okay. And then material performance and its measurement. First, structural safety. We need to measure the structural safety. The ability is to withstand stresses resulting from gravity, wind, thermal, or moisture removal of other sources. In terms of strength, ability to resist failure or excessive deformation under stress. Stiffness, deformation which is recovered when the load is removed. Toughness, ability to absorb energy by impact. Hardness, resistant to indentation. Creep, effect of long-term stress. So this is the structural safety. How it was measured, right? Okay. Next. Health and safety. How do we measure health and safety? So there should be no risk to health due to chemical or physical effect of the material both during and after construction. This is things that needs to be considered. It's very important. Health, safety issue. And then we have third one, fire. The material must behave acceptability in resisting fire spread, release of dangerous substance in fire, retaining satisfactory structural stability. Third one, durability. The material should fulfill the above performance criteria as required for the planned lifetime of the building. For example, we want to design the building to last for 30 years. It should be durable. It can last long until 30 years, not 10 years it already failed. So we need to design durability in terms of specific time, 30 years, 20 years, 25 years, and so on. The specification and standards. Almost invariable center around acceptable standard which provide a simple, convenient means of specifying performance levels. And then we measure performance in a carefully defined, reproducible manner. Right? This is about specification and standard. So we have to measure, we have first British standard, began to produce from the early 20th century. A committee representing manufacturers, researchers, users, government organizations. It operate only on a care and maintenance basis, eventually be replaced by the European codes. And then we have European code standard, provide a mechanism by which construction product material can be trained, used freely, thoroughly the European common market, produced by technical committee of the European Committee for Standardization. So we have a standard for design concrete, steel. Previously we used a British standard, BS code, and then it was superseded by the European code. We call it EN, in European code. So first British standard previously, and then we use European codes, BSEN, more latest version. Alright. So we already end our first topic, and then activities you can then discuss. We come to the activities. So discuss in the group why those problems occur to the structure. The first one, collapse interchange ramp of the second Penang Bridge. I think in last 3 years or 4 years, I think there's a collapse of interchange ramp in the second Penang Bridge. And then we have collapse flyover in Cyberjaya, and then we have column or piers, I think, were exposed to the environment, and causes the steel were exposed to the environment, and then the cover were cracked and then spoiled, were exposed. The steel exposed. So try to discuss in group where all this problem occurs, and then we'll discuss later on. Alright? Thank you for listening to my lecture, and then we'll see you again next week. Assalamualaikum. Bye.